Big data is emerging as one of the major technical and business challenges across many sectors, including industrial, commercial, and healthcare. More and more data is being gathered from increasingly diverse systems, even humans. Recent estimates suggest that over half of the world's total accumulated digital data was generated in just the last 2 years. The data explosion is well and truly upon us. Monitoring systems are capturing time series data from objects all around us on a daily basis. An object such as a wind farm could have many hundreds of sensors attached to it, all recording data thousands of times a second. If you record 24/7, as most systems do, this can quickly escalate in huge volumes of datasets, or as it is now described, big data. However, collecting, storing and managing big data is only half of the story. To derive value from this data, it needs to be mined to extract information. The data mining challenge is something that we, as individuals, do with implicit and unconscious ease, finding features or patterns in information which look interesting or which could challenge the presence of a problem. In big data applications, this is truly the needle in a haystack challenge. Mining the raw data to spot events or critical features allows an organisation to turn collected data into business intelligence, which they can act upon in managing their assets.
For a simple analogy of the data complexity issues, think about the children's series of Where's Wally books. The challenge is to spot the Wally character, but he's hidden amongst the chaos of hundreds of similar-looking characters in large, colourful and complicated scenes. With some careful scanning, we usually spot the woolly-hatted character in no time. Now, imagine getting a computer to do the same task. Our research here in the Department of Computer Science at the University of York has generated novel methods to deal with the complexity of pattern recognition tasks. These methods are now allowing businesses to generate intelligence from their raw data. Building on binary neural network techniques called Associative Memories, these tools provide the capability to drill down into data and look for pattern-based events on data collected from sensors on monitored systems. The tools are used in both commercial and research applications.
This research expertise on data mining and pattern recognition has led to the creation of Cybula, a commercial spin-out company which specialises in searching through large, unstructured datasets. The methods developed through research by the department have now been applied in many industries, including power generation, oil and gas industry, water industry, transport, healthcare, image analysis, and 3D face recognition.
The pattern recognition methods developed by the University of York are now being put to effective use in a highly novel project with Imperial College, King's College Hospital, and Cybula. The project is monitoring patients that are in intensive care as a result of a severe head injury. The pattern recognition tools are used to investigate the severity of brain tissue damage after a head trauma. This is done by monitoring an analysis of data collected from electrodes which are placed on the surface of the brain. Analysing this neural activity data is typically a manual task, which can take a highly trained clinician several hours to complete by scanning the data visually. The process can now be carried out automatically using York's pattern recognition software, as the data is streamed live from the bedside monitoring systems. This will provide neurosurgeons with immediate insight into the progression of the brain injury and inform their decisions on when and how to operate on the patient. The IT world is responding rapidly to the challenges of big data, and new data management technologies are in a constant state of development. One example is the open source project Hadoop. This provides a way to manage and process large, highly distributed datasets. Part of our research challenge is keeping abreast of these emerging technologies and developing our data mining solutions to integrate with them for both commercial and research deployment. Another ongoing challenge is the growing requirement to process big data problems in real time. That means searching through the data as it's being generated, rather than searching through it at a later date from a stored archive. As sensors increase in resolution, more data is generated, often in much shorter timescales. This requires sophisticated hardware and software solutions which can work together to process events in the data immediately. Our researchers are working on both aspects of this problem and are currently developing novel, easily scalable computer architectures that can be applied to these real-world data mining tasks.